Let's start with the highest level of design. And by highest level, I mean the least specific. So for example, if you're maybe designing a city, you might start by zoning out the different areas. We want some residential over here, we want some commercial over here, and we want some industry down here. Nothing else. That's just a very, very basic plan about how the city might work. And that's sort of how the architecture goes. We're taking it from requirements and now actually kind of coming up with an idea about how the app should function. And so that is why architecture is the highest level or the very top level of design. Architects are the link between idea and reality. So architects are people who implement architecture. Let's say that you have a building you're going to build. Before you break ground, before you even have any idea or any people on site to build this building, you're going to come up with some blueprints. There's going to be basically engineers that test the different parts, like saying we need at least a 15-foot I-beam here, or we need this type of construction over here. And you're going to be using basically this blueprint to build the building. Nothing's actually being implemented yet. It's just a design. And that's what the architect is doing. Someone had an idea for a building. The architect takes that idea and they build a plan to put it into reality. That's why they're the link between it. They're not actually the ones creating it, and they're not the ones who usually came up with the idea. They're the ones that are building that link between the two so that a construction team can build it and the person who had the idea can see it built. So that's the importance of the architects. And in software engineering, a lot of times we have to become the architects. So we have to take our requirements document and we have to transfer it over into a plan about how to actually build it so that we, again, maybe with a software programmer as well, we can implement the idea. And that's the importance of architecture, is providing that link. Now, architecture is important. It's something that cannot be fixed once implemented. Or in software, in the real world, it cannot be fixed. In software engineering, it might just be really, really, really hard to fix. But sort of view it as something that cannot be fixed once implemented. In software, bad architecture is something that can't be fixed with good programming. If you design the architecture of an app poorly, no matter how good your programmers are, it's still going to come out as a poor product that takes way too long to maintain and that is very hard to extend and make better over time. Imagine trying to fix the foundation of a skyscraper after it was 20 stories high. So let's say they've begun construction on this skyscraper and they're about this high, there's still cranes going and actually building the thing. But they realize that there's a foundational problem. The thing that the skyscraper is built on has a problem. What do you do to fix that? It's so much harder to fix it when you're 20 stories up than when you just have the foundation to look at it and go, actually, this foundation is not going to work. Let's destroy it and let's rebuild it really quickly. It'll be really fast turnaround time. Up here, though, you have to design some way to fix the foundation while not destroying the skyscraper. Or maybe the only way to fix it is you have to tear the whole thing down before you can build it again. That's a lot of times what happens in software engineering as well. We have to scrap a project and start over again. So architecture is really important. Let's sort of break this down and just jump into maybe a little bit more of a software-oriented example. Let's say that we have this server right here that takes in our app. Let's say that we have a component over here, something that our app does, and it contacts this server right like so. And let's say that we have another component over here and it contacts the app and then it gets feedback. And then we have another one down here, contacts this one, it contacts that, and then this comes out and goes into here, and this one goes up to there. And so we get this sort of really complex app that doesn't have a lot of sort of things. It's got a lot of these like crossbars that maybe go in and around. And so you can see that the architecture of this app might not be the best. And why might it not be the best? Well, let's say that we have a problem with our core interface, our core server, that the way that we designed it, maybe it's insecure. Maybe that there's a way easy for hackers to hack into this. And the only way to fix it is going to be to replace this server and change all of the protocols. Well, with an architecture like this, imagine taking this component out and putting a new one in. Because of the way it's linked with everything in here, we're going to have to reprogram every single one of these little steps, every single sort of loop in here that contacts this central server. We cannot hot swap the server out. We have to reprogram our entire app. Every single component has multiple areas that we would have to basically reprogram to get working correctly again. So in this alone, we would have to maybe reprogram 3 or 4 different endpoints. And then when they come in here and go out the other side, we'd have to reprogram that, how this data receives, how that data receives. It can get very, very complex. And you can get to a point where you look at the software and you go, there's no way we can change this out. Either we're going to have to stay with an insecure software, or we're just going to have to destroy it and start completely over, or abandon the software and basically just don't support it anymore. That happens a decent amount as well. So architecture, very, very important. We're going to go over some ways that you can sort of come up with an idea about the architecture and sort of refine that down so you have at least a good understanding about this stuff.